We are in section 7.5, and this is example 2. So this is one with Hooke's law and a spring. So we're told the force in general, if everything's constant, is proportional to the distance that the spring has moved. So F equals KD, or if the distance is measured along the x-axis, you could call this F equals KX. And so in example 2, example 2, they mention a force of 750 pounds was used to compress a spring 3 inches. And from its natural length of 15 inches. And it says find the work done in going an additional 3 inches. And now, so in lots of books, they're real big on giving you some initial numbers in order to find K, as opposed to just telling you what the spring constant is. My guess is that that's because maybe in physics, when you're working with things, you usually need to check the spring first. Nobody trusts the spring constant. I don't know. I'm not sure. Or it's just that extra math calculation that everybody thinks you need to do. I don't know for sure. But this says 750 is equal to K times 3. So K is 250 pounds per inch. And so we have our K. And so now we want to know what work is done to compress from 3 to 6 inches. Okay, because we compressed at 3 inches, now we want to go in another 3 inches, so from 3 to 6. And so again, each time we move it, so here's 3, here's 6. If I move it, delta x inches, then in here, that says the approximate work done in there is just the force times the delta x that I did. Well, what was the force? Well, it was either some value of x in here times 250. So I could use the 3 here, and then I just moved it a little bit, and so that compression took that x. So this is like 250 x times the delta x in here. And then any other spot in here, maybe here I'm at 4 and moving it to 4 plus delta x. X, but x was 3, so times 3. So it was that 750 pounds. Let me write that better. 750 pounds times the delta x. But by the time I'm at 4, in that case, the work is, my force times delta x again. But the force to compress here when I'm around 4 inches is 250 times that x, or 4, and then times delta x, or about 1,000 times delta x. So you see what I'm doing is I'm adding up a bunch of things where I'm taking the 250 times the current x value, because that was the force of compressing right in there somewhere, times the delta x. And so I want that to, I could call that xi, and so I equals 1 to n, and I want to let that n go to infinity, delta x go to 0. And so that's the integral from 3 to 6, because that's where I'm moving from, 250x dx. Well, this is simple enough to do. We get a 250 x squared over 2 from 3 to 6. And 250 over 2 is 125. So this becomes 125 times 6 squared minus 3 squared. So that's 36 minus 9 is 27. So we get 125 times 27. And that, according to the textbook, is 3,375 pounds, inch pounds, pounds, inches. I guess we do foot pounds, so sure, inch pounds. Okay, so that is example 2.